You're listening to LeadAI.dev, your daily updates on AI development. Today's topic is Sentence Transformers adds multimodal embedding training support. Here's a quick overview. Sentence Transformers now enables training custom multimodal embedding models that process text and images together, opening new possibilities for cross-modal search and retrieval. Now, let's ask our analyst about these developments. What's new? Multimodal embedding training in Sentence Transformers?
Sentence Transformers has expanded beyond text-only models with comprehensive support for training multimodal embedding and re-ranker models. This update enables developers to create custom models that process text, images, and combinations of both modalities through a unified training pipeline. The framework now supports popular multimodal architectures including site-based models, vision language transformers, and cross-modal re-rankers that can understand relationships between textual descriptions and visual content. The implementation provides native support for multiple model architectures, including Claude model, Siglet model, and custom vision language combinations. Training configurations support various loss functions optimized for multimodal tasks. Contrastive loss for embedding similarity, triplet loss for ranking tasks, and cross-entropy loss for classification scenarios. The framework automatically handles data preprocessing for different modalities, including image normalization, text tokenization, and batch construction that maintains modal alignment during training. Previously, developers needed separate frameworks and complex integration code to train models that could process both text and images effectively. The traditional approach required managing different preprocessing pipelines, loss calculations, and evaluation metrics across modalities. This new unified approach eliminates the complexity by providing consistent APIs for data loading, model configuration, and training loops regardless of whether the task involves text only, image only, or cross-modal scenarios. Support for Claude, Siglet, and custom vision language transformer architecture's unified training API that handles text, image, and multimodal datasets automatically built-in loss functions, contrastive loss, triplet loss, and cross-entropy for different use cases, automatic data preprocessing with modal-aware batching and normalization compatible with existing sentence transformers evaluation and inference pipelines.
Thank you for that analysis. Let's move on. Who benefits from multimodal embedding training?
AI researchers and machine learning engineers working on search systems, recommendation engines, and content understanding platforms gain the most immediate value. Teams building e-commerce search that matches product descriptions with images, content moderation systems that analyze text-image pairs, or educational platforms that connect textual concepts with visual materials can now train custom models tailored to their specific domains. Organizations with proprietary datasets containing both text and image content can create embeddings that capture domain-specific relationships not present in general-purpose models. Computer vision teams expanding into multimodal applications and NLP teams adding visual understanding capabilities represent the secondary beneficiaries. Startups building visual search applications, content creation tools that suggest images based on text prompts, or accessibility tools that generate descriptions for visual content can leverage this unified training approach. Research institutions studying cross-modal representation learning, multimodal information retrieval, or vision language understanding can streamline their experimental workflows. Teams working exclusively with text-only applications or those requiring real-time inference with strict latency constraints should evaluate whether multimodal capabilities justify the additional computational overhead. Organizations with limited labeled multimodal data or those needing immediate production deployment might benefit from using pre-trained multimodal models before investing in custom training infrastructure.
Great insight, really helpful context. How to get started? Step-by-step multimodal training?
Begin by installing the latest version of sentence transformers with multimodal dependencies using pip install sentence transformers. Prepare your dataset in the required format, pairs or triplets of text and images with corresponding labels or similarity scores. The framework expects image paths or PIL image objects alongside text strings, organized in datasets compatible with the Hugging Face datasets library or custom data loader implementations. Configure your model architecture by selecting a base multimodal model like ClipViBD32 or Sentence Transformer / ClipViB32 Multilingual V1 as the starting point. Initialize the sentence transformer with your chosen model, then define training arguments including learning rate, batch size, and loss function. Set up data loaders that handle both text tokenization and image preprocessing automatically through the framework's built-in callators. Execute training using the standard fit method, specifying your training data set, validation data, and evaluation metrics appropriate for multimodal tasks. Monitor training progress through loss curves and multimodal evaluation metrics like image text retrieval accuracy or cross-modal similarity scores. Save the trained model using the standard save method, which preserves both text and image processing components for deployment. Install with multimodal dependencies. Pip install sentence transformers, prepare datasets with text image pairs in Hugging Face datasets format, configure base model architectures CLIP, SIGLIP, or custom vision language model define training arguments. Learning rate to E5, batch size 16 to 32, appropriate loss function, use built-in evaluation metrics for image text retrieval, and cross-modal similarity, save train models with save method preserving all multimodal components.
That's a very interesting point. Tell us about competitive context. How this changes the multimodal landscape.
Compared to OpenAI's Skype training workflows or Google's multimodal research frameworks, Sentence Transformers provides a more accessible entry point for custom multimodal model development. While frameworks like MMF Multimodal Framework or LAVIS offer comprehensive research capabilities, they require significant infrastructure setup and deep expertise. Sentence Transformers bridges the gap by providing production-ready APIs with research-grade flexibility, making multimodal training accessible to teams without extensive MLOps infrastructure. The unified API approach creates significant advantages over fragmented solutions that require separate libraries for different modalities. Teams previously juggling transformers, TIM, and custom integration code can now manage entire multimodal pipelines through a single framework. This consolidation reduces dependency management complexity, simplifies deployment workflows, and ensures consistent pre-processing across text and image modalities. The framework's compatibility with existing sentence transformers ecosystems means teams can leverage established evaluation metrics, model hubs, and deployment patterns. However, the framework currently focuses on embedding and re-ranking tasks rather than generative multimodal capabilities like image captioning or visual question answering. Teams requiring state-of-the-art performance on specialized vision tasks might still need dedicated computer vision frameworks. The abstraction layer, while convenient, may limit access to cutting-edge architectural innovations that require low-level customization.
Good analysis. Let's continue. What's next? Future implications for multimodal AI.
The roadmap includes support for additional modalities beyond text and images, with audio and video processing capabilities in development. Integration with popular model architectures like LEVE, InstructLep, and other instruction-tuned multimodal models will expand the framework's applicability to conversational AI and interactive systems. Enhanced support for few-shot learning and domain adaptation will enable teams to customize models with minimal labeled data, addressing a common bottleneck in multimodal applications. Ecosystem integration focuses on seamless compatibility with vector databases, deployment platforms, and MLOps tools commonly used in production environments. Enhanced support for quantization, distillation, and efficient inference will make multimodal models more practical for resource-constrained deployments. Integration with popular serving frameworks and edge deployment tools will streamline the path from training to production deployment. This development signals the maturation of multimodal AI from research curiosity to practical development tool. As training custom multimodal embeddings becomes as straightforward as fine-tuning text models, we expect broader adoption across industries requiring cross-modal understanding. The democratization of multimodal training capabilities will likely accelerate innovation in applications combining textual and visual information, from enhanced search systems to more sophisticated content understanding platforms.
Great analysis. So, what are the key takeaways from all of this?
Install sentence transformers to access unified training APIs for text image models. Use CLIP or SIGLIP base models as starting points for domain-specific multimodal embedding training. Prepare datasets with text image pairs in Hugging Face format for seamless integration. Leverage built-in evaluation metrics for cross-modal retrieval and similarity tasks.
And what market signals should our listeners watch for?
Multimodal training democratization. The integration of multimodal training capabilities into sentence transformers represents a significant lowering of barriers for custom multimodal AI development. Previously, teams needed extensive infrastructure and expertise to train models processing both text and images. This accessibility shift will likely accelerate adoption of multimodal AI across smaller organizations and specialized domains, potentially disrupting markets currently dominated by large-scale pre-trained models. The unified API approach reduces development complexity and time to market for multimodal applications. Cross-modal search market expansion. Enhanced accessibility for training custom multimodal embeddings will drive growth in cross-modal search applications across e-commerce, content platforms, and enterprise search systems. Organizations can now create domain-specific models that understand relationships between textual descriptions and visual content within their specific contexts. This capability enables more sophisticated product discovery, content recommendation, and information retrieval systems that were previously limited to general purpose models or required significant technical investment. Framework consolidation trend. The move toward unified APIs for multimodal training reflects a broader industry trend toward framework consolidation and developer experience optimization. As AI applications increasingly require multiple modalities, developers favor integrated solutions over managing separate libraries for text, vision, and cross-modal tasks. This trend suggests continued pressure on specialized frameworks to provide more comprehensive solutions or risk being displaced by unified platforms that offer comparable functionality with better developer ergonomics.
What should developers and operators do with this information?
Evaluate current text-only embedding pipelines for multimodal enhancement opportunities within 30 days. Prototype multimodal training on existing text-image datasets before committing to production infrastructure. Benchmark custom multimodal models against general-purpose alternatives like OpenAI Slipe on domain-specific tasks. Plan gradual migration from separate text/vision models to unified multimodal embeddings for reduced operational complexity.
Thank you for listening to LeadAI.dev. Stay tuned for our next daily updates in this rapidly emerging market.